I'll be doing the term 1 week 2 applied math quiz. So let's get started. Where did I go? Which of the following are vector quantities? Select all that apply. So a vector quantity is a quantity with a magnitude and a direction. Right? We should know this. Time, obviously wrong because I can't say 40 seconds to the north. Mass, obviously I can't say 10 kilograms south. That's wrong. However, please don't confuse mass with weight. Weight is a vector, mass is not, because in the end weight is a force and a force is a vector. Velocity, you can say 20 meters per second north, that's absolutely correct. Displacement, you can say I walk 10 meters east, that's fine. Force is a vector because obviously you have to say 10 newtons to a certain direction, right? You can't just tell me 10 newtons. 10 newtons rare. How do I calculate with this? And even when you draw a force diagram, right? Let's say you have a box with a force of 15 newtons being applied to it. You can see here that I have an arrow that indicates which direction is the 15 newtons in. So it is a force, or I mean it is a vector. So, question 2. In the square ABCD, M is the midpoint of CD and N is the midpoint of AD. Sorry if I'm talking a little bit quickly. No, I did this quiz 4 times now and I kept making incorrect things. I don't know, it's a long story. This is my 4th take on the clip, basically. Vectors A and B are represented in magnitude and direction by AB and AD. What is, in terms of A and B, the expression of vector MN? Now, the way I explain vectors, and the way that I taught vectors to myself in IGCSE math, which is last year. Remember, we took this in algebra. So this is basically just a quick refresher, and I'm assuming you all know this, but I'll still explain it anyway. So, what you have here is basically, let's say there's a person here. Bob, okay? Let's say hi to Bob, everyone. So Bob, okay? Bob is at point M, and he wants to go to point N, which is here. Sorry, I drew the line wrong. I can't see where point N is. Here, okay? However, the road that takes Bob from M to N is closed, right? We can't have that road. So what we're going to do instead is we're going to take the long way. What is the long way, you might ask? Which is MD, بعدين D to N. Okay? So, how do we get Bob there? How do we find that? How do we find out what MD is and DN are? Right, so we're going to write an expression. MD plus DN is equal to MN. Okay, now that we know this, how do we find these vectors? So, first of all, AB and DC are parallel, and they would have the same magnitude. So, DC is going to have the magnitude of A. Right, the entire thing, not until M, the entire thing. Why am I clarifying this? You'll see now. So, I'm not trying to go in the direction of D to C. That's the opposite of where I want to go. I want to go to N. Why am I going the other way around? So what we're going to do is we're going to go in the direction of C to D. So the vector CD, not the magnitude of CD, just its direction. So CD is obviously going to be the opposite of DC, right? So it's going to be negative A. However, I'm not starting off at C. I'm starting off at M. And M is given to me as a midpoint. So, M to D, if you think about it, right? M to D is only halfway there. It's only half of CD. So it's going to be half of negative A. We found vector MD. Now I'm going to rewrite this as negative half of A. They're the same thing. Okay, now that we know this, MN, same exact thing, or sorry, DN. To find vector DN. Now, it's given to me that AD is B, right? It's given here. AD, this entire thing is B. However, I'm not trying to go from A to D. I'm going in the direction of D to A. Not the magnitude, just its direction. So D to A is gonna equal to negative B. Okay? Now, I'm not going fully from D to A. I'm going only from D to N. So again, we're only going halfway. So that would mean that D to N is half of negative B, which is going to be rewritten as negative half of B. Now that I know this, I have my vectors now. I'm going to put a box around them in blue just so no one gets confused. So this is the first vector here. And this is the second vector here. Okay, so the answer to this question is very obviously going to be half of A minus half of B. Done. That's it, because I'm just combining them. Right? Again, we said MD plus DN is MN. So MD is negative half of A plus negative half of B. Half of A minus half of B is MN. Done. Moving on to question 3. Find 2D vector given magnitude and bearing. That's the description. Never mind. Consider a vector V of magnitude 8.0 having the same direction as another vector v1 of magnitude 4.0 at a bearing of 120 degrees. So the rest of the question is useless to me, and they're trying to trick us here by writing this, cross it out, this magnitude of 4.0, we don't need it. They want us to write vector v in the form of a radical bi plus cj. Vector v is given to have the magnitude of 8.0. Why do I need the magnitude of vector v1, which is 4.0? This is useless to me, right? So all I need is the bearing, is the direction, because they told us that vector v is the same direction as vector v1. So if I find the direction of vector v1, I can obviously find the direction of vector v. Let's draw our plane. North, south, east, west. Now, in bearings and another topic called mariner's compass. Hella, you'll find it now. So bearing and mariner's compass, MC. So that's an and. What did I open? I have to remove this now. So in bearings and mariner's compass, the conventional way to get the angle, to get a positive angle, the positive angle is in direction of the clockwise direction. Okay? Why am I saying this? This is blending in with the blue here. So going clockwise will give me the positive angle. However, in normal mathematics and conventional math, the polar or the Cartesian coordinate system, okay, which is how we're expressing our vector. This is called Cartesian notation. So Cartesian, the way to get a positive angle is to go counterclockwise. So the positive angle is in the direction of the counterclockwise. Okay, now let's draw our plane again, because I erased it. North, south, east, west. Okay, so first let's find the direction of the vector v. So it said that it's on a bearing of 120 degrees. Again, in bearings, you're starting off you're starting off clockwise. Where? From the north axis. So from here. Okay, so this here is 90. You should know this because, you know, the angle between two quadrants is 90 degrees. So 90 and then 30 degrees here will give me a sum of 120. So this is vector v with a magnitude of 8 units. Okay, now here's what's different. This is 120 degrees, right? However, in, again, the Cartesian notation or the Cartesian coordinate system, this is actually negative 30 degrees. Okay? Because you're not starting off clockwise from the northernmost axis. Where are you starting from? You're starting off counterclockwise from the positive x-axis. So it's this. You're starting off in this direction. Okay? So, if you're going down like this, you're going in the opposite direction of the positive angle. You're going negative, right? You're approaching the negative y-axis. Meaning that, since you're only going 30 degrees from the positive x-axis, this is negative 30 degrees on the Cartesian coordinate system. Okay? Now, there's two ways to find the positive angle for this. You can obviously do this. Then this is 90, this is 180, this is 270, and then this part here is 60 degrees, right? Because this is 30, this is 60. So it's going to be 90 plus 92. So this is going to be, let me just rewrite it now fully. This is 60, this is going to be 90, 180, 270, and then 270 plus 60. This is going to be 270 plus 60, which is 330. So this entire angle is actually 330 degrees. Okay? Which is what we're going to use. The other way is obviously 360 minus 30. Gives me 330 degrees again. This is the faster way. And I would recommend you use that. Okay, now that we know this, I know this is a bit unclear, but I'm going fast because there are like 3 other questions with the exact same topic. You will get practice on it more. So, now that we know this, right? It's 330 degrees. How do we convert? This, by the way, this is basically polar. Okay, this is the polar coordinate system right now. We're trying to convert this into Cartesian. Okay, so to convert from polar to Cartesian, this is what you do. For the x component, or the, where am I again? The x component is gonna be r, where r is the magnitude, cosine of the angle theta, the positive angle that we found, not the negative one. You can use negative 30, it gives you the same answer, but preferably use 330 degrees. And for the y component, it's going to be r sine theta. R is the magnitude, theta is the angle, again. So, now that we know this, we're going to apply this. Okay, very easy. So, polar to Cartesian. X is going to equal 2. The magnitude is 8, it's given. 8 cosine 330 or 8 cosine negative 30 will give you the same answer. Let's do it on a calculator. 8 cosine 330 for radical 3. And for the y, it's going to be 8 sine 330, which is going to give me 8 sine 330 negative 4. So this in Cartesian notation is written as, I'll write it up here, for radical 3 I minus 4j. Okay, this is our vector v. Okay, so now that we have the form that they wanted in, let me erase everything here. We have the form that they wanted in, a radical bi plus cj. A is going to be 4. Okay, b is going to be radical 3, or b is just going to be 3 since it's radical b in the question. B is going to be 3, and then c is going to be negative 4. Done. This is the end of this question. Again, I know it was a bit unclear, but you'll get more practice since there are more questions on it. Question 4. ABCD is a pentagon with vectors B, Q, R, S, and are represented in magnitude and direction by A, B, B, C, E, D, and A, E respectively. So determine for each expression to what vector it corresponds. B, E, E, C, A, D, E, C, D, whatever these are the options. Negative P plus R, negative P. So this in this direction, BA is P, right? So AB is P. So BA will be negative P. So this will be here will be negative P. Okay, and then they want R. So R is AE. So this is what we're just gonna find. Negative P plus R is BE. Okay, that's done. Negative P minus Q. So minus P minus Q plus R plus S. Okay, now I'll just rewrote it from my reference. So I'll write it again here. Minus P minus Q plus R plus S. So you might notice that tracing the path here doesn't really work, right? Because minus Q is this direction, minus P is this direction. Sorry, minus P and then minus Q, right? Minus P minus Q wouldn't really work, right? Because minus P is this. So you're going from B to A. Then how are you going to go from C to B? That doesn't make sense, right? Well, remember that you can write it as this. Minus P minus Q plus R plus S, like this. Then you remember that addition is commutative. So it's going to be minus Q minus P plus R plus S. It's the exact same thing. So minus Q is C to B, right? Then minus P is B to A, so C to B, B to A, then R is A to E, then S is D, E to D. So you're going CB, then BA, then AE, then AD. So this is actually vector CD. Again, you're tracing out the path. So that's the answer, CD. Now, minus R plus P plus Q. Minus R is E to A. So this is minus R plus P plus Q. So you can see that it starts off at E and ends at C. It's EC. Sorry. EC. R plus S, A to E, then E to D, AD. Done. Points A 4 and 7 and B 2 and negative 2 and vector BC are 3 and 4 in the same coordinate system. Okay, in Cartesian form is, again, this is Cartesian form on I and J. This question, by the way, is wrong. The answer is incorrect. Okay, I'll show you the correct answer and the correct way to do it. There's two ways to do it. There's actually multiple, but I'll do the one that is the easiest. Then I'll do the way that I usually do. So you would realize that AC, vector AC, if you think about it, right, is actually just vector AB plus vector BC. We have vector BC given, so we just have to gonna find vector AB, and we have points A and B. Now, how do you find vector AB? Remember that a vector is the terminal point, which is the final point, minus the initial point. Okay, so AB is going to equal the terminal, which is B minus A, so 2 and negative 2, minus 4 and 7, which makes negative 2 and 5, or sorry, negative 9. Okay, now, we have vector AB now. So minus 2, 2 minus 4 is negative 2, negative 2 minus 7 is negative 9. So we're going to add this. So minus 2 minus 9 plus BC, which is 3 and 4, gives me 1 and negative 5. So the correct answer is actually 1i minus 5j. This is the correct answer. However, it's given here as 1i minus 1j. This is wrong. This is the wrong answer. The quiz is incorrect for this question. The other way to do it is you can find point C, okay, and then you can do C minus A. It's the same exact method but in a different order. So, question 6. The polar coordinates, this is what I was talking about, right? This is another example of this polar to Cartesian thing. So, the polar coordinates of point A are 4 and 30 degrees. Okay, basically, the polar coordinates of a point is gonna be written as r comma theta. R is the magnitude, and then theta is the angle. Okay, so what are we gonna do here? Again, we're gonna remember the conversion. The conversion is for polar to Cartesian, it is x, the x component is gonna be equal to r cosine theta, and the y component is gonna equal to r sine theta. Sorry. Okay, so I'll also leave out the form here. So r is magnitude, and then theta is the angle, just for your reference, yani. Okay, so how do we convert this now? So the x part, or a, because it's a, ai plus bj, a is gonna equal to 4 cosine 30. Do this on a calculator. 4 cosine 30, you're gonna get 2 radical 3, which is 3.46. However, if you notice here, they tell you give your answer to 2 significant figures, so you round to 3.5. Okay, now b, which is the y component, is gonna equal to 4 sine 30. And you know that sine 30 is 0.5, so it's actually 4 times 0.5, which is 2, but again, 2 significant figures, so 2.0. This is my answer. Moving on. Consider the following 2 position vectors. Okay, we're gonna need to get our plane out for this one. So, north, south, east, west. A vector A in magnitude 12 kilometers in the direction of E 60 degrees S. This is Mariner's compass. This is the formation of Mariner's compass. So, vector A is in the magnitude of 12 kilometers of a direction east 60 degrees south. So, you start off at east, okay? Then you're gonna go 60 degrees south. So, it's somewhere here. Okay, this is 60 degrees south. So, let's say this is 60 degrees here. Okay, which A is equal to 12 kilometers. Now, B is at a bearing of 300 degrees. So you start off from the north. Why does it keep taking me here? You start off at the north, then you go 300 degrees. So this here is 90. Let me go in red. So 90, 180, 270. Then somewhere here is gonna be 300. So B is 220 kilometers. Now, sorry, I'll draw that vector back. So it's here, and then A is here. Okay, so now that we have this, let me just draw this a bit longer. Okay, 60 degrees we set here. Okay, now they want us to find the sum of A and B. Okay, so first of all, let's find the angle in the correct notation, right? In the correct plane, or in the correct conventional way. So we're starting with angle B. Now you're gonna start counterclockwise from the positive x-axis. So you're gonna go like this. So 90, and then remember we said this was 300. So this here is gonna be 30 degrees, because this here will make it 270, meaning that this part here is 60. So this is gonna be 90, and then 90 plus 60. Let me just rearrange this. 90 plus 60 will give me the angle of B, theta B, let's say, is gonna equal 150 degrees. So writing this in polar coordinates, it's gonna be 20, 150 degrees. Now, theta A, how would we find this? So let me erase all of this now. Why did it erase the plane? So let me erase this part here. Okay, B, we don't need it anymore, but why not? We'll leave it there. So this, if you think about it, is actually going negative 60 degrees, right? Why does it keep taking me to random apps? So 60 degrees, this here, if you're starting off in the Cartesian notation, you're starting off from the positive x-axis and you're going counterclockwise to get a positive angle. However, if you go clockwise 60 degrees, this is actually going to be negative 60 degrees. So to find this, we're going to do 360 minus 60 to give me that the actual positive angle in this case is 300 degrees. Why does it want to write? Okay, so now the theta A is 300 degrees. Writing this in Porter, it's going to be 12, 300 degrees. Now we're gonna have to change this from polar to Cartesian. So so this is for B, right? So this is B, this is A. So B, so the x of B is gonna equal to 20 cosine 150, which gives me 20 cosine 150, negative 10 radical 3. Meanwhile, the y of B will give me 20 sine 150, which if you think about it is the same thing as 20 sine 30, so it actually should be just 10. So let me just make sure. Yeah, it's 10. Okay, now x of A is going to equal 12 cosine 300, which is the same thing as 12 cosine 60, I think. So 12 cosine 300, 6. Y of A, sorry, let me rewrite that. Y of A is going to equal 12 sine 300, which is equal to 12 sine 300, negative 6 radical 3. Okay, now that we have this, we have our, we can now write it in the form of I and J. So this is going to be negative 10. So in terms of A, or sorry, let's write it in B first. B is actually going to equal to negative 10 radical 3 I plus 10J. Okay, and for A, it's going to be 6I minus 6 radical 3J. Now, we want to find A plus B. So, we're going to combine the I with the I and the J with the J. So, it's going to be 6 minus 10 radical 3I okay, and for the J, it's going to be 10 minus, or sorry, let me write this down here like this. 6I minus 6 radical 3J. We're going to write 10 minus 6 radical 3J. Okay, this question is done. Fairly easy and simple. Moving on. I'm just activate to not disturb. Drag and drop the correct terms from the box below to express each of the following using Mariner's compass. So, 60 degrees. So let's draw our plane out first because this makes it easier for us. SEW. So, 60 degrees is going to be obviously positive 60 degrees. So, we're going to go somewhere here. Let's say this is actually 45. Wait, it's going to be something like this. So, this is 60 degrees. Okay, it's going to be east. Or wait, no, this is because we're starting counterclockwise. This is going to be 30 degrees. So, it's going to be east and then 30 degrees north, because remember, you're starting from the east line and you're ending at this line. The difference between these two is going to be 30 degrees, right? Because you have 60 degrees here, and again, this will make it the positive angle. So, 30 degrees east, 30 degrees north, done. 300 degrees, so we're going to start off, we're going to remove this now. Okay, so 180, 180, 270, 300 somewhere here. So this all is 300 degrees. This can be written as west 30 degrees north. Wait, what? How? 1 second. West 30 degrees north. West 30 degrees north would put it here. Doesn't really make sense though. 1 second. Okay, so my bad. what I thought was they wanted me to convert it from like the traditional angle system into Mariner's compass. No, they want the angle, this angle, in terms of Mariner's compass as its rotation. So in Mariner's compass, as I said, you go clockwise for the positive direction. So that would make that N is 0 degrees, E is 90 degrees, S is 180 degrees, and W is 270 degrees. So for this now, 60 degrees would lie somewhere here, right? So there's a 60-degree difference here, which makes that there's a 30-degree difference here. Okay, so that would make it east 30 degrees north. Okay, that's how you do that. Now, let's find the 300-degree angle on Mariner's compass, not using the traditional conventional math method. 180, 270 is here, so we're gonna go 30 degrees up of 270. So this is 30 degrees. Okay, this would make it west 30 degrees north. Again, my bad. I thought they wanted me to do how would I say this? The traditional angle system, so where I start from counterclockwise and go all the way to 60 degrees. But no, that's not what they want. They want the angle that is this angle already given in Mariner's compass to be expressed using its notation. My bad for that. So just as a quick recap, 60 degrees on Mariner's compass, so 60 degrees somewhere here. Okay, so this would make it 60 degrees from the north, which means 30 degrees from the east. Basically, in Mariner's compass, you go with the direction you start with. So let's say in this case it's east. Then go up by a certain amount. Okay, so it's gonna be go by a certain angle, by like or not go up or down. Let me explain. So you go by a certain angle, theta. Okay, and theta, where theta's in degrees, in a certain direction. So for example, north. That would mean that I'm gonna start at the east point and then go up, because north is up, by theta degrees. That's basically the notation. So that would give me for 60 degrees. Now 300, 270 is here, so 300 somewhere here, 30 degrees here, which would mean that I'm gonna go west 30 degrees north. Moving on. Given A, B, A, C, and V. Okay, this is very easy. This is like the other question that we did, but I'm gonna repeat it. So, coordinates of V. They want V is 3AC minus 2BA. We don't have BA. We can find BA though. BA is gonna equal to B minus A, so 5, 0 minus 3 and 4. So, this is point B here, this is A. Now, 5 minus 3, which makes 5 plus 3, 8, and 4. Or sorry, negative 4. So, now that we know this, right? Or this doesn't really make sense though. Because B to A, that means you're going back 8. Yes, I flipped it. That's right, I flipped it. Yes, okay, my bad. I'm a bit sick today, so I'm not focused. So it's gonna be minus 3, 4, minus 5, and 0. This is A, this is B, because remember it's terminal, minus initial. So it's gonna be minus 8 and 4. This is vector BA. So now that we can do this, now we have vector C, so AC is given, so vector V is going to equal to 3 times 3, 4, minus 2 into negative 8 and 4. So this is actually going to equal to 9. We're going to distribute the 3. 3 times 3 is 9, 3 times 4 is 12. Plus minus 2 minus 8 is positive 16, right? Because negative make a positive. And this is going to be negative 8. Now minus 2 1 times 4 is going to be negative 8. So 16 plus 9 is 25. 12 minus 8 is 12 minus 8 is 4. So in Cartesian notation it's going to be 25i plus 4j, which is what we have the correct answer as. Now, if the tail of V is located at negative 1 and 2, the head at its point is at point blah blah blah. Now, basically, a vector, you can draw it like this. This is the tail, which is the initial point. And this is the head. This is the terminal point. Okay, so now that we know this, we want to find the head. So V is 25 and 4. Right, this equals to the terminal point, which is the head. So I'm gonna write x of the t, of which is terminal, and y of t, minus 1 or negative 1 and 2. So we're gonna take this to the other side. We're gonna take this to the other side. X t y t is equal to 25 4 plus 1 and 2, negative 1 and 2. So it's gonna be 24 and 4 plus 2 is 6. This is my answer, 24, 6. Question 10. Although we only have 6 more questions. Two forces acting on a particle are given by F1, I minus 2j newtons, and F2, 2i plus 6j newtons. What are the components of the resultant force F? So here, remember when we combined I with I and j with j with the other, and like another question, we're going to do the exact same thing here. So I with I, 3i. Okay, j with j, negative 2 plus 6 is going to be plus 4j newtons. Okay, now, what's the magnitude of the resultant force? As the magnitude of a vector v is going to be equal to x squared plus y squared. So, here, in this case, the magnitude of f is going to equal to 3 squared plus 4 squared, which is going to equal to 9 plus 16, under the radical, which is going to equal to radical 25, which equals 5 newtons. Done. Question 11. The initial velocity of a bullet is given by v equals 9i plus 3j, the unit vector in the direction of v. Now, the unit vector, there's a formula for it, sorry. The formula for the unit vector is, given like this. So when you see me writing I and j like this, okay, this means that the unit vector, this thing here means unit vector. So v as a unit vector is going to equal to the original thing, so the coefficient of v over the magnitude of v. What do you mean? I'll apply this now. Just wait. So let's find the magnitude of v. It's going to be 9 squared plus 3 squared. It's going to give me 9 squared plus 3 squared, 3 radical 10. Okay, so now to find the vector v originally. So it's going to be 9. I'm taking the coefficients. So the coefficient of 9 and 3, of I and j, sorry. 9 and plus 3 over their magnitude, which is 3 radical 10, 3 radical 10. Okay, this is what I mean. You take the coefficient of I and j and put it over the magnitude. This is what the direction of the unit vector is. Now, taking this on a calculator so you can find it to the 2 decimal places, 3 radical 10. The first one is going to be 0.94, but they wanted to 2 decimal places, 0.948, so 0.95. I. So sorry, I'm supposed to write this as I and that's j here. Plus, I think this was, so now it's going to be 3 over 3 radical 10. 0.316, so you round to 0.32 j. This is my answer. Moving on. What polar coordinate pair responds to the position vector -4 and -3? So, for this, what you can do here, right? There's a button on the calculator to convert between Cartesian, which is what we have here, to the vector, or to polar. So follow with me on the calculator. Now, because this is only an AMS, they're not going to ask you to write this down, right? No one will know how you solve this. But in a periodic, when the time comes for the mechanics periodic, okay, I will explain how to do it by hand, because there are 4 cases for when x is less than 0, x is greater than 0, and it's a long story. So what I'm going to do is I'm going to teach you the calculator trick only for the AMS, but when the time comes for the periodic, I'm going to teach you how to do it by hand in a course practice quiz. So press shift, then the plus button, okay? Polar, or sorry. Let me just figure out. I don't think it's yeah. So you're gonna press shift then minus, not plus. Shift then minus, which will give you rec, REC. Now you're gonna write the first coordinate, which in this case is -4. Okay. Shift. Where's the comma? Shift and then the right bracket. Okay. Then you're gonna write -3 here in this case. Press enter. Why shift? Wait 1 second. This is wrong. Whatever, it's supposed to work. I don't know why it's not working for me, but you can do rec, so REC, negative 3 or negative 4 comma negative 3. This will give you, I think I flipped it. Wait. Yes, I flipped it. Wait, you're right. Yes. So here, I'm supposed to convert, yeah, it's not track, it's pole. So, again, I'm sick. So, you're gonna press shift plus, ignore what I told you before, shift plus, which will give you pole. You're gonna press negative 4 comma negative 3. It will give you r as 5 and theta as negative 143.1 degrees. Now, remember, the coordinates for the thing for polar is going to be r comma theta, so it's going to equal to 5 comma negative 143. However, you may notice that we don't have negative 143. So what you're going to do is you're going to subtract 360 minus 143, 217. So the answer is 5217. Just as a quick recap, I'll solve it again. To change from Cartesian to polar, you press the pole button on your calculator. It's like this. Okay? It's written as this. Basically, what you do is shift, then plus. So shift plus. Enter the first coordinate. So open the bracket x comma y. So doing it like that, it's gonna be negative 4. Then you press shift on the right bracket. Then press negative 3. Enter. It will give you r as a value and then theta as a value. If you have a negative theta, if you have theta is less than 0, just do 360 minus the absolute value of theta. So don't enter 360. If you have negative 30, for example, don't enter 360 minus 30. That's going to give you 390. You don't want that. No, you want 360 minus positive 30. If theta is negative 30, of course. So this is just a quick note for it. Again, when the time comes for a periodic, for a chance it might come in the written part, I will teach you how to do it by hand. But right now, since it's going to be a computer part, it's absolutely useless for me to teach you how to do it by hand. So I'll teach you the trick, which is this. Now, say you wanted to change from polar to Cartesian. This is where you use the rec thing, the one that I made an error about. So rec, then you write theta, or sorry, r, which r in this case is 5, and then r theta, which in this case was 217. So let's do this on a calculator. Obviously, you don't have to do this now. I don't know if it came in a later question or not, but we're teaching it to you from now. So shift minus r in our case was 5. Shift, so you press 5, then shift, right bracket to get the comma, 217, close your bracket, equals, x is gonna be negative 3.99, but because obviously we took an approximation, it's not 217, it's actually 216 point something. We will round to negative 4. Y is also given as negative 3.009. We'll take it as negative 3. So this is our coordinate. This is just a trick you should learn from now, just in case it'll help you later. So the angle OA makes with the positive x-axis. Okay, this is a very nice question. So vector OA is shown in the diagram below. So vector OA is, sorry, how much is this? Wait, 1, 2, 3, and then 1, 2, 3, 4. Negative 4i minus 3j, right? Because you're going negative 4 back on terms of the x-axis, and you're going 3 down in terms of the y-axis. So now that you know this, okay, what you're gonna want to do is you're gonna find the angle that it makes with the positive x-axis. Now, first of all, I want you to find the angle that it makes with the negative x-axis, just in case, because they might ask it in the computer part. So you want this. This is theta. Okay. How do you find it? You do tan inverse or arctan y over x. So the coefficient of j over I. So in our case, theta is gonna equal to tan inverse of negative 3 over negative 4, which gives you an angle of tan inverse, where is tan inverse, negative 3 over negative 4, 36.86, 37 degrees. Okay, we're gonna round to the nearest degree. Now, this is the angle it makes with the negative y-axis. So it's negative x-axis, sorry, we're here. This is this angle, this is theta. However, they want this angle all the way here. Okay, so how do you do it? you can see here, right? This line here is 180 degrees, and then this line here is 37 degrees, right? I'm just explaining why. So it's gonna be 180 plus 37, which gives me 217. Now, the formula for this, okay? The formula for this is, this was just an explanation. You can memorize the formula, so I don't recommend it. I'm teaching you how to get it. So it's going to be 180 plus tan inverse of y over x, okay? Provided that the vector is making an angle with negative x-axis, not theta is with negative x-axis. Okay, so to recap, I'm gonna recap this again because I know it was a bit confusing. Our vector is negative 4i minus 3j, right? This is our vector. So to find the angle that it makes with the x-axis in general, okay, we're just gonna do tan inverse of negative 3 over negative 4. Okay, this gives me 37 degrees. Now, this 37 degrees is this. Okay, this is 37 degrees. However, they want it with the positive x-axis. How do we get it? Okay, the positive x-axis is the angle between it is all of this, right? Now, you notice that this part here, from the positive x-axis to the negative x-axis, is 180 degrees. Okay, so 180 degrees is the angle between the positive x-axis and the negative x-axis. How do we add? We're gonna add this. Sorry, I don't know how to speak. I don't know how to explain this well because it's a bit of a confusing topic. So we're gonna add 37 to 180 to get 217, which is the angle that this makes with the positive x-axis. Since if you can see, you can actually divide this entire thing, this entire circle here, not the circle, but this entire, let's say, quadrant, into 180 degrees here and then 37 degrees here, which is what we have, right? So 37 plus 180 gives me 217. Now the bearing of OA. So you notice that this here, so we're gonna find this angle. Basically, what it's gonna be is 217 minus 90, and then subtract that. Yeah, so this is gonna be, I'm not gonna get it for myself. This is gonna be 127 degrees. Okay, this is this angle, right? You know, why am I doing this? Because bearings, you're starting from the north, right? And you're going clockwise. In the conventional Cartesian system, you're starting from the normal, from the positive x-axis, and you're going counterclockwise. So what we're doing is I'm canceling out the 90 degrees that they have in common here. Like, look, if I start it off like this, this is the angle, and then this is going to be the bearing. You can see that they share this part here in common. This part here is 90 degrees. So I'm canceling it out to find how much it actually is in terms of the bearing. So without this 90 degrees, it's actually 127 degrees, right? Okay, we agree on that. Without the 90 degrees that we have in the first quadrant, which is this part here, we have 127 degrees. So what we're going to do is we're going to do 360 minus 127, because that will give me the angle from the clockwise direction, not the counterclockwise direction, which is going to be 360 minus 127, 233 degrees. Done. Okay. Now, part C, two possible ways to write this using Mariner's compass is, okay. So, Mariner's compass, obviously we have our bearing, which is all of this, 233 degrees. Again, let's rewrite the notation. So, 0, 90, 180, 270 here. Okay, just as a quick recap. So, two possible ways to describe OA using Mariner's compass. So we're going to concern ourselves with the west and the south. So in this case, it's going to be 180, 270, right? Our angle here is 37 degrees. Okay, remember this. So the way to go is west 37 degrees S. Let me just make sure this the first one's correct. West 37 degrees S. Yes, because you're starting off at the west, you're going 37 degrees south. Now, you can also write it as south. What is 90 minus 37? 53. So this part here is 53. So between the S and the vector, it's gonna be 53 degrees. So S 53 degrees W. And these two are two ways of writing this angle. Moving on, the position vector of A has a magnitude of 5 kilometers acting on a bearing of 30 degrees W. This is another application of the polar thing. So going like this, N, W, right? N is 0, W is 90. So N 30 degrees, W is going to be somewhere here. So this is going to be 30 here, then 60 here. Meaning that the actual angle is 60 degrees, right? So it's gonna be 5. Remember, in the polar coordinate system, it's r comma theta. So r magnitude is 5, and as I said here, starting from the positive x-axis to the vector, it's actually gonna be 60 degrees, right? So 5 comma 60 degrees. Now we're gonna have to convert it. So really quickly, this is where we use rec on the calculator. So I'm gonna teach you how to do it using rec. So shift, since I already taught you twice how to do it with by hand, I'm just gonna teach you how to do it by calculator so you can familiarize yourself with it. So shift minus 5 comma, so shift right bracket, 60, close the bracket, x is 2.5, y is 4.3. Okay, so, yes. Now, you might be asking me, why is the answer here negative 2.5? Because this doesn't really account for it really well. So what we're gonna do is we're gonna shift this properly. So, just give me a second. Okay, so I just realized I flipped east and west. So as you can see, I am not awake at all. So N, W, 0 to 70, 30 degrees west, so you're just gonna shift 30 degrees like this. So this is 30 degrees, done. So 30 degrees like this. Okay, this makes it starting from the positive x-axis all the way to here, 90 plus 130. It's gonna be 90 plus 130 is 150, right? Yes. So 150 degrees. So the actual notation is 5 and r comma theta. It's 5, 150 degrees. So what you're gonna do is you're gonna press shift, then minus, then 5 comma, just shift right bracket, 150, close the bracket. You're gonna get x as the other way around. What did I do? 90 plus 30 is not 150. Wait, no, 90 plus 30 is 120. Oh my god. So shift. For the millionth time, shift. I should have just done this by hand. 5 comma 120. Close the bracket. There we go. Okay, so this is 120 degrees, not 150. Because 90 plus 30, apparently I can't do it. It is 120 degrees. So x is negative 2.5, y is 4.3. But I'll just do it by hand, just so I can show you guys properly. So ST, whatever, doesn't really matter to me anymore. What we're gonna do is we're gonna do, for the x component, it's 5 cosine 120, which is gonna equal to 5 cosine 120, negative 2.5, and then y is equal to 5 sine 120, which is gonna equal to 4.3. So it's going to be negative 2.5i plus 4.3j. Moving on. Given the, okay, position vector. Position vector means you're starting from the origin which is 0, 0. Remember on the graph, you have the origin here, which is this point. Yeah, that's what that is. So why did I erase my graph? So like this, and then negative 3 and 2. So let's say negative 3 is here, then 2 is up here. This is where the vector is. This is m. So OM is going to be like this. So it's going to be negative 3i plus 2j. Because you're starting from 0, 0, and then you're going to negative 3, 2. So what is the shift here? You're going 3 backwards, then 2 up. Question 16, which is the last question. Consider two vectors v and u such that v is ai plus 7.2j plus and u is 5.4i plus bj. Let r equals u plus v, negative 5i plus 2.4j. What are the values of a and v? So for this, right, r, they want is gonna equal to 5i plus 2.4j is equal to u vector u, which is 5.4i plus bj plus vector v, right? V is ai plus 7.2j. Now, what do you do here? You're gonna group your I with I and then your j with j. So, negative 5i is equal to 5.4i plus 7.2j. Or sorry, plus, where is it? Plus ai. Right? We're grouping this I, let me just do it in red. This I is going to be equal to this I plus this I, right? Because in the end, this is our final vector. So solving for A, you can do this with an equation solver or on your head, basically. Take this to the other side. A is going to equal to negative 10.4. This is our answer. Okay. And now for B, let's say 2.4j is going to equal to bj plus 7.2j. Okay, so taking this to the other side, 7.2 to the other side, bj is going to equal to negative 4.8j, cross the j with the j obviously, so b is going to equal to negative 4.8. These are our answers, and this is the end of the quiz. Good luck, guys. Enjoy the rest of your day.